Okay, so now we're going to look at Lab 10, which coincides with Chapter 9 on regression and correlation in our book. We're going to be doing just simple transformations, right? And so you have all these examples to try, but I want to pick one of them to help you with so you can see how it's done. So let's look at bear weights and age. And I have this set up in, I opened up in Minitab and I opened up bear, right? So the first thing we need to do is we want to display a scattergram. We want to display a scattergram of the paired weight versus age. And does it appear that there's a relationship with weight and age? And we're going to use weight as on the x-axis and age on the y-axis. So we go to graph, scatter plot, simple, and we're going to go to weight on the x-axis and age on the y-axis. Let me make sure we have that right. So down here, weight is the predictor, right? And age is y. Okay, so we just click OK. And here it does look like as their weight increases, their age is increasing. This is in months. You don't have a 200-year-old bear. This is in months. Okay, so that was our first question. So you just kind of sketch. Here's our graph here. You just put a bunch of dots in that make it so it looks like on your lab that it's kind of in this. You don't have to get it exactly on here. Or you can copy this onto your lab too. You can copy the graph onto the Minitab lab and cut and paste it. Okay, copy and paste it. So the next question asks us to find the value of the linear correlation coefficient R. To do that, for weight and age. So to do that, we go to stat, basic stat, and correlation. Stat, basic stat, and all the way down here to correlation. And we're going to click in age and weight, and it doesn't really matter which order you click it in. We're going to do the Pearson correlation. We're going to see later when we do Chapter 12 that Spearman-Rowe is a non-parametric, but for this class we're doing Pearson. For this chapter we're doing Pearson. So click OK. And my R, the Pearson correlation coefficient, is 0.749. Is this significant? Okay, so part B says, what is the correlation coefficient? And it's 0.49. Assuming a 5% significance level, do we think it's significant? Well, the p-value is 0, which is certainly less than 0.05. So yes, there is a significant linear correlation between the weight and the ages of the bears. Next, so the next question says let's find the equation of the regression line. So to do that, we go to stat, regression, fit regression line. Our response in here is age. It says so in the lab, look, it says in here to use response being age and the predictor being weight. So the predictor is weight. It is a continuous predictor because weight is a number, right? Not a category. And then you just click OK. Now we're going to get an awful lot of stuff here, right? But so we get all of this. You're going to have to scroll, regression analysis, all of that. I do discuss all of this in the lecture, but it's not important for the Minitab lab. And then here we go. Here's our regression equation, right? So age is equal to 5.59 plus 0.2074 times weight. That's where you put in right here. So how much variability in age can be explained by weight? That is the R squared value. Here's the R squared value, 56.10%. That says that 56.10% of the age is explained by the weight. So R squared, R-SQ stands for R squared. says that 56.10% of the bear's age is explained by his weight. To do the last problem, what is the best predicted age of a bear that weighs 300 pounds? You just go into here, age is equal to 5.59 plus 0.204 times 300, and you'll get a value for age. Okay, so I could do it for you. Let me see. So we have 300 times 0.2074 plus 5.59, so that is a 67.81 month old bear. That's the predicted age of the bear if the bear weighs 300 pounds. That is as much as you'd need for all of these. We can do transform the data from days to month by just multiplying each age by 30, and you can do that through the calculator. If you have trouble with this problem here is not that important. If you ended up skipping it, I wouldn't take points off for you. Okay, so that's all. The rest of these are similar to that. Okay, here we're doing bear weight and chest size. Here you're going to enter this data into two different columns and do the same thing. Here you're going to enter this data into two different columns. Do the same thing here. You're going to enter this data into two different columns and do the same thing here. Okay, so all of this is very much like the example I just showed you, and you should have no trouble doing the rest of the lab. If you do, please email me and I will do my best to help you get straightened out.